1 to the power infinity, and so on and so forth. And we have seen how to evaluate the limits of such functions, right? So,
Yes, ma'am.
And we did a few problems, but let me try some typical ones from the exercise only, so that it gives you an idea that at with what kind of problems we can make certain manipulations. Like for example, just look at your अभी तो exercise सामने नहीं होगी तुम लोग के, you know. Say you have question number 44 from the exercise. It says we have to evaluate limit x tending to infinity x to the power 5 into sine 1 by x minus 1 by x plus 1 upon 6x cube. Okay. Now it's x tending to infinity. Okay. So if I just see if x tends to infinity, definitely 1 by x tends to 0. Okay. So this term becomes 0, this becomes 0, this becomes 0. So this whole term within the bracket actually becomes 0, right? But because I have x to the power 5 here, so it's like infinity. So basically it's an infinity into 0 form. Okay. Now to reduce it to 0 by 0, because I have x to the power 5 here, the easiest way is that I can write this as limit x tending to infinity sine 1 by x minus 1 by x plus 1 upon 6x cube whole upon 1 upon x to the power 5. Right. Now, when x tends to infinity, as in the earlier case, the numerator is still 0. And because of this term here, this actually becomes a 0 by 0 form. Okay. So now this term as it is totally apt where we can apply the L'Hopital's rule. But what I see here is that this 1 by x is present everywhere. Okay. And if I just apply the L'Hopital's rule, this 1 by x might create problems in the sense that we'll have to write the derivative of sine 1 by x, which will be cos 1 by x into minus 1 by x square, and so on and so forth. So what I can do is, instead of continuing with 1 by x everywhere, we can make a substitution as this, like we assume 1 by x to be u or y or whatever you want. Okay. Now, our original problem is in terms of x. What we are doing is we are replacing our variable x with a variable u. Okay. In the original problem, my x approaches infinity. Okay. And since my u is nothing but 1 by x, so as x approaches infinity, it's so obvious that my u will approach 0. Okay. And I can rewrite the whole problem as limit u tending to u 0 sine u minus u plus u cube by 6 whole upon u to the power 5. लिख सकते हैं ना? Because we have substituted 1 by x as u. Okay, now it's a simple term. And your u approaches 0. So when your u approaches 0, this is still a 0 by 0 form. So the form has not changed. It was 0 by 0 here. It is still 0 by 0 here. But now the term which we have got is much simpler. Okay, in the sense that we have direct polynomials here. And we have a trigonometric function with just one variable u. Okay, so now we can apply L'Hopital's rule here as many times as we want, and then we can get the answer. इसके आगे तो कर लोगे ना अपने आप?
Yes, ma'am.
Yeah.
Yes, ma'am.
So sometimes it happens that with just a little substitution, your problem becomes easier. Okay. Similarly, I think I gave you 2-3 problems to try that day, which involve the limits where the limit turns out to be e, right? अब बिल्कुल उसी पे ही based just look at your question number 45. Your question number 45 says that you have to find an unknown constant a so that limit x tending to infinity x plus a upon x minus 2a to the power x is 5. Okay, this is the problem that we have to solve. Now, if you just look at this problem, a is an unknown constant. Okay, now it's not necessary that for every value of a, this limit will exist, and for every value of a, this limit will be equal to 5. Okay, so it is only for, we have to find that specific value of a for which, number one, this limit exists, that is for sure, and number two, the limit is equal to 5. We have to satisfy these two conditions. Okay, now as x approaches infinity, now the moment we have x approaches infinity, I can write this problem as the left hand side basically as, okay, let me write it here. My left hand side is equal to limit x tending to infinity. I can write this as 1 plus a by x upon 1 minus 2a by x and whole to the power x. लिख सकते हैं ना ऐसे?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, and this further I can write as limit x tending to infinity. I can separate out the numerator from the denominator and it becomes 1 plus a by x to the power x upon 1 minus 2a by x to the power x. Is that right?
Yes, ma'am.
Yes, ma'am.
Yes.
Right. Now, can you use the results that we did the other day? What will be the numerator equal to? X tending to infinity. See, basically this is nothing but limit x tending to infinity 1 plus a by x to the power x upon limit x tending to infinity 1 minus 2a by x to the power x. अब बताओ, what is the numerator equal to?
0.
What are infinity?
What is the numerator equal to?
E.
What is you? What is lim? मतलब इतने दिन में भूल गए? हाँ? क्या किया था?
1 to the power infinity.
क्यों? जो उस दिन, अब अपनी कॉपी खोलो पीछे, अगर लिखा था उस दिन तो क्या लिमिट निकाली थी बताओ? टर्न बैक योर पेजेस एंड सी. क्या था वो?
Limit x infinity 1 plus 1 upon x to the power x is equal to e.
हाँ, तो अब तुम्हारे पास क्या है? You have the result that, और इसीलिए उससे मिलते जुलते मैंने 3 प्रॉब्लम्स दिए थे ना करने को, वो किए नहीं. अब मैं यहाँ पे एक रफ वर्क लिख रही हूँ. You have limit x tending to infinity 1 plus 1 by x to the power x as e. और मैंने होमवर्क में और क्या निकालने को दिया था बताओ? एक और दिया था शायद.
Minus 1 by x to the power x.
हाँ, ये कितनी थी? ये
1
कितनी
by
आई?
1 by e.
1 by का मतलब क्या हुआ?
1 by e.
-1.
Yes, ma'am.
राइट. और एक और दिया था या यही दिया था?
Yes, ma'am.
Ma'am, 1
Limit
by 2x to the power 2.
Limit x tending to infinity
1 plus 1 by 2x.
1 plus 1 by 2x to the power 2x.
2x.
ये कितनी आई?
E.
E.
ये भी ई आई.
Yes, ma'am.
ठीक है. अब इसको अगर आप इसको यूज करते हो कहीं, तो इसको यूज करके यहाँ का रिजल्ट लिख सकते हो.
e
Yes,
to
ma'am.
the power a.
Yes, ma'am.
कैन यू रिपीट? अभी किसने आंसर किया था?
Ma'am, e to the power a.
Anybody else? अच्छा,
Ma'am, E.
E.
ए कहाँ जाएगा?
Ma'am,
मैं
e
बोल
a.
रही हूँ. जस्ट क्विकली, अब तुम्हें मेथड तो याद हो गया ना कैसे करना है, राइट? इवैल्यूएट दिस क्विकली. Limit extending to infinity 1 plus 2 by x to the power x. Just evaluate this quickly, जैसे उस दिन करी थी. तो क्या आएगी देखो. वैसे ही करेंगे ना. Let y equal to this, then take log on both the sides, then take the limits, and then whatever is the final answer, e to the power, that will be your answer, right? हाँ जी, क्या आया अनन्या?
Sir.
e to
E
the
to the
power
power
2.
2.
e to
e
the
to the
power
power
2.
2.
सबका आ गया ना e to the power 2.
Yes,
So
ma'am.
that means this limit is actually e to the power 2. तो यही तो हो रहा है. 1 plus whatever is the term is e to the power plus that term. 1 minus whatever is the term is e to the power minus. So if you take 1 minus 2 by x to the power x, it will be e to the power minus 2. So that means if you use this result and if you want, you can evaluate it separately. This limit will be nothing but e to the power a. And what will be this limit? The denominator?
E to the power minus
e to the
2A.
power minus 2a.
E to the power minus 2a.
Minus 2a.
Okay. So that means our left hand side is actually nothing but e to the power 3a.
A.
Okay. But what does this problem says? This problem says that this limit exists and must be equal to 5. Okay. So for this limit to exist, my left hand side must be equal to right hand side. That means I must have e to the power 3a equal to 5. Now can you find a? Calculator hai sabke paas, and calculators will be allowed in your exams, don't worry. So e to the power 3a equal to 5 का मतलब क्या हुआ? कैसे निकालेंगे? What do we do?
3A is equal to ln 5.
Log 5.
Log कौन से वाला लोगे अब? Because you have e,
Natural log.
we'll take natural log. यही लिखेंगे ना?
Yes, ma'am.
And natural log of e is 1, so that means 3a is natural log of
Our
5, which means a is nothing but natural log of 5 upon 3. Can we find the value? कर सकते हैं ना कि नहीं?
0.536 समथिंग आ रही है.
हाँ वही आएगा. That's fine. Perfect. 0.5 something something. Round it off to at least 3 decimal places. Whatever value you are getting, round it off to at least 3 decimal places. Okay?
Yes, ma'am.
अब इसी तरह से ही, like say just look at your question number 57 now, because you'll have problem in the exams. You are going to get problems like this only, where you have to find the unknown constants. Now see, in question number 57 it says find all values of a and b. Now we have two constants, unknown constants, a and b, such that what happens is, it says so that limit x tending to 0 of sine ax plus bx upon x cube is equal to 36. Okay. Now see again, we have two unknown constants. Okay. If we have two constants, then how many equations do we need to find their values?
Two.
Two. Yeah, we need two equations to solve them and we get the values of two unknown constants. बिल्कुल ठीक. Okay. So that means somehow we have to use two conditions so that we are able to reduce those conditions in terms of equations and solve those equations to get the values of a and b. And those two conditions or those two equations, again, how do we get those two equations? By using two conditions. What are the two conditions? The two conditions, number one, saying that the limit exists. That is my first condition. And number two, saying that the limit must be equal to 36. So somehow we have to use these two conditions, translate or convert those conditions into equations, solve those equations to get the values of a and b. This is the objective. Okay. Now, if I just again look at my left-hand side here, now when you take the limit as x approaches 0, so sine ax, sine 0, 0, bx, when x approaches 0, even this term becomes 0 and you have a 0 here. So basically, your left-hand side is actually a 0 by 0 form. Okay, so if I have checked it, it's a 0 by 0 form. So we can apply L'Hopital's rule here directly. Okay, so your left-hand side actually then, after applying L'Hopital's rule, gets reduced to limit x tending to 0. Now, we have to differentiate the numerator. So the numerator derivative will be what? A cos ax plus b upon 3x square. यही आएगा ना? After taking the derivative.
Yes, ma'am.
Right? Now, if I take the limits here as x approaches 0, so as x approaches 0, this term becomes what? A. Okay, now, there is no x here, and so as x approaches 0, it still remains
A plus
b.
B.
So it becomes a plus b by 0.
0.
Right? Now, if a and b would have been any constants, we would have concluded that some constant upon 0 is nothing but infinity. Okay, but the problem says that the limit is not infinity. The limit is actually 36. So this amounts to saying that for the limit to exist and be finite, even this term must end up in a 0 by 0 form. Okay, so that is the first condition we are going to use. So that's why we'll say, but since the limit is 36, therefore a plus b by 0 must be a 0 by 0 form. And for this to be a 0 by 0 form, what condition do we need? That means our a and b should be such that a plus b is 0. ये एक equation आ गई हमारे पास. right? So a plus b is 0 का मतलब क्या हुआ? My b should be nothing but minus a. Okay. So if using this condition that a plus b is 0, we get one relationship between a and b. Okay. But since there are two unknown constants, we need one more relation. Okay. And we are assuming that this relation holds good between a and b. That means we are assuming that a plus b is also 0. So we are assuming that this is nothing but a 0 by 0 form. So if it is a 0 by 0 form, that means we can apply the L'Hopital's rule once again. Okay. And because of that reason, your left hand side again becomes equal to, we can write it as now limit x tending to 0. That means we can differentiate it once again because the limit, it's still a 0 by 0 form. And if you differentiate it once again, this will be nothing but, I'll have now minus a square sine ax. Now b is a constant, so its derivative will be 0 upon 6x. Okay. Now, this term, if you take the limit as x approaches 0, the numerator is minus a square into sine ax. When x approaches 0, sine ax is 0 upon, and denominator is 6x, so it is still a 0 by 0 form. So that means we can apply L'Hopital's rule once again, and it becomes minus a cube cos ax upon 6. Okay. And when you take the limit as x approaches 0, then this term is actually nothing but minus a cube by 6, your left hand side. Okay. But we are given that this limit not only exists, but the limit is also equal to 36. So that means, but, okay, let me write, but we are given that the limit is 36. So because the limit is 36, that means minus a cube by 6 must be equal to 36. So what do you conclude? How much is a?
minus 6.
Is
6.
minus 6. तभी तो a cube minus 36 होगा, minus 36 into 6 होगा, ठीक है ना? So if a is minus 6, how much was your b? Which was
6.
minus a, so b will be 6. So that means for a equal to minus 6 and b equal to 6, this limit will exist and will be equal to 36. For any other values of a and b, this will not be the case. Okay. So we are not using anything else except for the basic logic of L'Hopital's rule. Now, sometimes we have to use basic, logic of exponents also. Like your question number, this is 58. Yes, this is an interesting problem and it's an important one also. It says, find a certain value of C. Now, इसमें भी हम सिर्फ लॉजिक यूज करेंगे और L'Hopital's rule, और कुछ नहीं यूज करेंगे. We have to find a certain value of constant C. No, for. It says, for a certain value of C, the limit is limit x tending to infinity, x to the power 4 plus 5x cube plus 3 to the power c minus x is finite and non-zero. Is finite and non-zero. So we have to find c and the limit. Okay, this is the problem. Now see, you have, I'm writing it again, limit x tending to infinity, x to the power 4 plus 5x cube plus 3 whole to the power c minus x. यही है ना हमारे पास. Now, if I just look at this as x approaches infinity, I mean, for if c is positive or whatever, as far as the look at one glance is concerned, it looks like an infinity minus infinity form. ठीक है ना? Because x is approaching infinity. Of course, there is a bracket here also. Okay, because your x is approaching infinity. So this is an infinity minus infinity form. Okay. Now everything depends upon what? C, right? The problem says that for a certain value of C, that means there exists some value of C for which this limit is finite and is non-zero. Okay, we have two conditions again here, that the limit has to be finite and it is not zero, definitely. So our problem now is to not only find that value of C, but also to compute the limit. Now, if we know C, computing of limit becomes an easier thing. Okay. So that means to find C is the most important part here. Okay. Now, if I just see this x is still okay. This is just x. So it is not going to create much problem here, and it does not have an exponent also to it. The problem is this term. Okay. Now, this term here within this square bracket is actually a polynomial of degree 4, right? Now, this whole polynomial of degree 4 is again to the power c, right? Now, if we go by the logic of exponents and if we try to expand this term to the power c by using binomial expansions or whatever, it's just that everything is the highest power is going to be something like 4c, right? Baki jitni bhi aayenge, that will be less than those terms. The powers which is going to be the less than those terms. So this is the maximum thing that can happen. Okay. Now, if I see here, if I say, let's consider for c, say more than 1 by 4. Okay. See, what I am actually trying to do is just see how this term is going to behave. That means I'm just going to look at the behavior of x tending to infinity, x to the power 4 plus 5x cube plus 3 to the power c. सिर्फ इस टर्म का अभी बिहेवियर देख रहे हैं, बिकॉज ये टर्म तो है ही माइनस इंफिनिटी. ओके. नाउ if c is greater than 1 by 4, okay, कुछ भी ले लो, greater than 1 by 4, what is going to be the limit of this term? Say half ले लो. Half is greater than 1 by 4. है ना? Say 1 ही ले लो. 1 is also greater than 1 by 4.
Yes, ma'am.
तो क्या लिमिट होगी इसकी?
Infinity.
प्लस या माइनस?
Plus.
Plus. Okay. So that means this term is going to be plus infinity if c is greater than 1 by 4. What happens if it is less than 1 by 4? Just look at the behavior of only this term and it will give you an idea. What happens if c is less than 1 by 4? Then what will be the limit? 1 by 4 से कोई छोटा नंबर ले लो.
Positive infinity.
Take a number less than 1 by 4. then what will happen?
मैं प्लस इन्फिनिटी आएगा.
Are you sure?
यस मैम.
कैसे? क्या नंबर लिया तुमने 1/4 से छोटा?
लेंगे तो 1 आएगा. 1/8.
मैम 0 आएगा.
0 कैसे आएगा?
-4
आएगा.
नहीं बोलो क्या आएगा? अगर 1/4 से छोटा नंबर लेते हो वो तो क्या हो रहा है?
इन्फिनिटी.
करके देखो, हवा में मत करो, लिख के देखो. If c is less than 1/4, what is happening to x to the power 4c?
upon infinity.
क्या? बोलो फिर से.
मैम 0.
0 और आंसर
मेरा भी 0 ही आ.
0 आ रहा है.
मैम अगर c को -1 लेंगे तो वो तो मींस डिनोमिनेटर में चल जाएगा ना ये टर्म. एंड फिर वो चीज इन्फिनिटी हो जाएगा तो 1/∞ इज इक्वल टू 0.
यस मैम.
और कोई इस पे कुछ और रोशनी डालना चाहेगा?
और तो इन्फिनिटी आ रहा है.
मैम अगर हम c को 0 लेंगे तो
को -1 लोगे तो भी आंसर आ रहा है. You have to take it to be less than 1/4. This term will become 0. And what will happen is that your limit of the term x to the power 4 plus 5x cube plus 3 to the power c minus x becomes plus infinity. क्योंकि ये plus infinity है तो आगे की terms भी and so on so forth. This will be if c is less than 1/4 and this becomes minus infinity if c is more than 1/4. So, but then we are given that the term, the function has a finite limit and is non-zero also. So that means the only possibility left with us is to see how the function behaves when c is equal to 1/4. So when c is equal to 1/4, your terms, your function actually takes the form x to the power 4 plus 5x cube plus 3 to the power 1/4 minus x. Okay. Now it becomes an infinity minus infinity form again. And to solve this, now you have to make substitutions. Okay. अब इसमें फिर हम यही करेंगे. We'll put जैसे पहले वाले में किया था ना, because अब जैसे नॉर्मली हमने क्या पिछली बारी किए थे एग्जाम्पल्स जो इस टाइप के थे fx minus gx, तो वो ऑलरेडी रैशनल थे. So what we could do is take the denominator LCM लेके and then we could reduce it to 0/0 or infinity by infinity form. But इस केस में ऐसा नहीं है. So to bring in the denominators, to bring in the fractions, again we can put u equal to 1/x. So फिर बात वही रहेगी that as x approaches infinity, your u is going to approach 0. And what will happen is your terms will now be different. Okay. I'm leaving it as a homework. इसके बाद आसान है, थोड़ा सा और दिमाग लगेगा, but वो बड़ा mechanical सा दिमाग है. So just use this substitution, let u equal to 1 by x, substitute here and then evaluate the limit. But definitely the value of c for which the limit is going to exist is 1 by 4. So we have obtained the value of c, now obtain the value of the limit. The answer for this is, I'm telling you, is 5 by 4. The limit is 5 by 4. So try doing it now. Okay. और अगर अभी भी कंफ्यूजन है कि वो प्लस इन्फिनिटी माइनस इन्फिनिटी कैसे आया, तो इसको आराम से खाली टाइम में बैठ के अच्छे से ट्राई करना. ठीक है.
एक बार में आप बता दीजिए थोड़ा सा मैम, वहाँ पे जहाँ पे आपने प्लस इन्फिनिटी एंड माइनस इन्फिनिटी लिया है.
तभी तो कह रही हूँ. अब वो अपनी फुर्सत मैंने तुम्हें हिंट दे दिया है. Take the value powers of c and then evaluate the limit. For c more than 1 by 4, this limit will be plus infinity. For c less than 1 by 4, this limit will be minus infinity. Because for c less than 1 by 4, ये term 0 हो जाएगा जब limit लोगे as x approaches infinity. So it will be 0 minus infinity, which makes it infinity.
Ma'am, why you took only 1 by 4? Like there are thousands of the numbers or more than that. So
सबसे पहला sentence मैंने यही बोला था. If we use binomial expansions to expand this term, the maximum power of x is going to be 4c. अब ये 4c greater than 1 होगा, 4c because it is x to the power 4c. If 4c is greater than 1, that means you have x in the numerators. If 4c is less than 1, you have x in the denominators. And your limit is as x approaches infinity. See, if you have x in the numerators, ये x तो कहीं ना कहीं cancel होगा, because how do you use the binomial expansions? कहीं ना कहीं terms आएंगी ना, x की reducing powers में आएंगी ना powers. तो ये x तो कहीं ना कहीं कैंसिल ही हो जाएगा. इसीलिए ये लिमिट प्लस इंफिनिटी ही इसी से गवर्न रहेगी लिमिट. बाइनोमियल एक्सपेंशन तो याद है ना. जब हम बाइनोमियल एक्सपेंशंस यूज करते हैं तो बात की, इसीलिए ये लिमिट हमेशा प्लस इंफिनिटी ही रहेगी व्हेन c is more than 4. Why? Because you have 4c more than 1, so you have all x in the numerators. But if 4c is less than 1, तब प्रॉब्लम आएगी ना. और 4c less than 1 का मतलब क्या हुआ? c less than 1 by 4. तभी मैंने ये दो ली. सबसे पहले मैंने यही बोला ना, 4c, ये देखो मैंने लिखा भी हुआ है. ये हमको ये देखना है कि ये टर्म कैसे बिहेव करेगी. इस टर्म का बिहेवियर किस पे डिपेंडेंट है? जो इस टर्म की हाईएस्ट पावर आएगी वो कहां से आएगी? फर्स्ट टर्म से, बिकॉज मैक्सिमम पावर इसकी 4 है. बाकी तो डिमिनिशिंग पावर्स है ना. तो डेफिनेटली x और एक्सपोनेंट कितना है? c. तो मैक्सिमम कितना हो जाएगा? x to the power 4c. उससे बड़ा थोड़ी कुछ जाएगा. इसका मतलब 4c या तो ग्रेटर देन 1 होगा, या 4c लेस देन 1 होगा, या 4c इक्वल टू 1 होगा. तीन ही केसेस आए ना हमारे पास. और वो भी हम क्यों कर रहे हैं? बिकॉज आर x इज अप्रोचिंग इंफिनिटी. ठीक है.
yes, ma'am.
इज दिस ओके नाउ? ये क्वेश्चन आया हुआ है एक दो बार, इसलिए इसको अच्छे से समझ के लिखना. ओके. इसी तरह की ही प्रॉब्लम्स.
मैम ऊपर तो लिखा है कि c greater than 1 by 4 plus infinity, और यहाँ पे क्लब जब किया है
यहाँ पे c लेस देन 1/4 प्लस इन्फिनिटी, ये ग्रेटर देन होगा ना?
नहीं, c लेस देन 1/4 माइनस इन्फिनिटी है।
यस मैम, c
यहाँ पे आपने लिखा है कि
ओह, मैंने
C
उल्टा लिख दिया। ओह यस यस यस, मैंने उल्टा लिख दिया। हाँ, दिस इज प्लस इन्फिनिटी व्हेन c इज ग्रेटर देन 1/4 एंड माइनस इन्फिनिटी इफ c इज लेस देन 1/4। अब ठीक है?
यस मैम।
ठीक ठीक। And for c equal to 1/4 it is finite, and उसके लिए आप ये सब्स्टिट्यूशन कर सकते हो, and the answer is 5/4. I'm giving you the answer. Okay, बिल्कुल ऐसा ही है तुम्हारा ये क्वेश्चन नंबर 59। अब ये खुद ट्राई करना, ठीक है? आई थिंक ये 4.5 जो हम कर रहे थे ना, दिस इज मोर देन इनफ। इतनी ही ट्राई करो। क्वेश्चन नंबर्स तुम ट्राई कर सकते हो 3 ऑनवर्ड्स ही करो, या 1 से भी देख सकते हो। 1 till
मैम वो पेज, वो क्वेश्चन नंबर्स डिफरेंट है जो
मैंने
हमारे
3rd एडिशन भी शेयर किया हुआ है, उसमें डिफरेंट नहीं है, तभी मैं दोबारा नहीं भेज रही।
मैम वो खुल नहीं रहा था।
खोल किस पे रहे हो, सिस्टम पे या फोन पे?
हम सिस्टम पे ट्राई किया था पर खुला ही नहीं।
सिस्टम पे तो डाउनलोड होके खुलेगा, क्यों नहीं खुलेगा? खुल रहा है।
पता नहीं वो ब्लैंक आ रहा है, वो लोड ही नहीं हो पा रहा है पूरी तरह से।
चलो मैं फिर वो फिर से भेजती हूँ, ठीक है? इसके क्वेश्चन नंबर्स 1 till 49, देन 53 till 59, that's it। 4.5 ये ट्राई करो, ओके?
ओके मैम।
बाकी तो हो जाएगा, ठीक है? अब इसके बाद 4.7 करना है, जिसमें हमको करना है एप्लीकेशंस, ओके? एंड एप्लीकेशंस of maxima minima or application